this video we're going to start a new topic. The topic is actually called pulleys and wedges. So in your notes you can have a new section for pulleys and wedges, but before we kind of go into looking at pulleys and wedges, which are the two kind of main types of questions in it, we need to just look at Newton's second law, because it's a really important law that's used a lot in this topic, but it's also used a lot in Leaving Cert physics. So it's a really important law that you need to know. So what is Newton's second law? Well, it's that the rate of acceleration of an object is directly proportional to the force applied. That's the main kind of bit of it. But the actual definition that you need to learn for Leaving Cert is a little bit longer than this, but this is just the main bit of it really. So what does that actually mean? Well, let's look at an object like this. And let's look at another identical object like this, and both objects are on the ground. Let's say for object number 1 I apply a force of 10 newtons. Now newtons is the unit of force, which I'm sure you've come across before. And for the second object I apply a force of 20 newtons. So obviously twice the force that's on the first object. Notice as well how the length of the arrow actually represents the size of the force, which is what we always do in applied maths. Both of those objects, assuming that there's not loads and loads of friction, are going to move to the right. But what they're going to do is they're going to go from having a velocity of 0 to a velocity of something else. So they're going to accelerate. Which block do you think, block A or B, will accelerate more? Well, it makes sense that the second block, A, is going to accelerate more. There's a bigger force, so obviously its increase in speed is going to be much bigger. And that's basically what Newton's second law is. The rate of acceleration, in other words, how much something accelerates by, is directly proportional to the force applied. So what that means is as the force you apply increases, the rate of acceleration will increase also. If you decrease the size of the force you apply, the rate of acceleration will decrease. So making the red arrows bigger makes the blue arrows bigger. Now how we write that mathematically is A, and this symbol here, F. And this symbol stands for is directly proportional to. And as we could almost do another lesson on directly proportional to, and we will talk about it again. But for the moment, this is all I kind of want you to understand, that as F increases, A increases. When you look at this though, is there anything else that might affect how quickly A or B increases? Say we did exactly the same experiment again, but this time we have A like this, and this time we have B like this. And we apply a force of 10 newtons and 20 newtons. In this case, would we get the same result, given that B is twice or 3 times as big as A? Well, clearly in the first case we assumed something. We assumed that the mass was constant. But in reality, that's not always going to be the case when you're comparing two things. So this is just a relationship. In order to form an equation, we need to take into account every single variable that affects the acceleration. And acceleration is also going to be affected by the mass of the object. So let's think about this one. If the mass gets bigger, what do you think will happen to the rate of acceleration? For a bigger mass, will you have more acceleration or less acceleration for the same force? And I'll try and make that clear if I make this. Let's say we have exactly the same force on these two objects. For the bigger mass, which is B, will we have a higher acceleration or a lower acceleration than with A? Well, hopefully it makes sense that we'll have a lower acceleration. And you know that from everyday experience, that if you try and move something that's bigger, has a bigger mass, it's harder to move. Mass is actually kind of a measure of how difficult it is to move something, how difficult it is to change something's speed. When the mass of something gets lighter, it gets easier to accelerate it or to make it move. So acceleration increases as mass decreases. Now the way we write this mathematically, this is the opposite to our top relationship, whereas one goes up, the other goes up. Here we have as mass increases, acceleration decreases. So mathematically we write this as A is proportional to 1 over m. And how we'd say that is they're inversely proportional. Inversely proportional. So these are the two main things that affect how much something will accelerate by. 1, the force applied to it, and 2, its mass. Now you could talk about other things like friction and things like that, but for our equation, this is all we use. If we put both of these together, we get A equals F over m. And hopefully you can kind of see where that's coming from. We have A is proportional to F, A is proportional to 1 over m. So if you kind of combine them, you can figure out what the actual acceleration is. A is equal to F over m, or it's more commonly written as F equals ma. And that's known as Newton's second law. So for leaving cert physics anyway, you'd have a definition to learn for Newton's second law, which is not too different to this one up here that I showed you a minute ago. This one over here. But obviously it's a little bit more detailed. But you also need to know the equation that goes with it. And the equation that goes with it is F equals ma. There is another thing that you will talk about in physics as well, and when you're deriving equations or when you're looking at equations. We define 1 Newton, and remember 1 Newton is the unit of force, as when 1 kg is accelerated by 1 meters per second. So the definition for 1 Newton is when 1 kilogram is accelerated by 1 meters per second squared. And that's just by definition, because you could actually say, well, 1 Newton is when 2 kilograms is multiplied by 1 meter squared, or 2 kilograms is accelerated by 1 meter squared. So you will meet something about when you're deriving equations of k, and k is a constant that we put in here, and in this case k is 1. The force is 1 Newton when 1 kilogram is accelerated by 1 meter per second. Now you don't have to worry about that yet, I'm just kind of throwing that at you just as a little extra. So this is the first video. I'm going to stop it here and start it again in a minute where we do an example. I'll stop it here so you can pause it and take notes, and if you have any questions, don't be afraid to ask.